Yasha. At the end of the previous lesson, your task was to prepare salts from the following reactants: sodium carbonate, zinc oxide, sodium hydroxide, zinc carbonate, hydrochloric acid, and sulfuric acid. Let's join John in the lab to see how some learners managed this task.
How many salts did you find?
I found 4 salts.
Me too.
Me too.
Excellent. Tell me about them.
Well, I got sodium chloride by reacting sodium hydroxide with hydrochloric acid.
But what about the balanced equation? Did you get that part too?
Yes, I did.
Tell me about it.
NaOH plus HCl
Good.
will give me NaCl plus H2O.
That's brilliant.
I also got sodium chloride, but I used a different method.
Tell me about the method you used.
Well, I took hydrochloric acid and mixed it with sodium carbonate.
That's a good method. But what about the balanced equation? Could you get that part right?
Here's my answer, but I can't balance it.
Well, give it to me anyway.
It's NaCO3 plus HCl, which gave me NaCl plus H2O plus CO2.
I see the mistake. The formula for sodium carbonate is not NaCO3, but is Na2CO3.
That's right. Let's fix it.
That was quite careless of me. I know that sodium ions have a charge of +1 and carbonate ions have a charge of -2.
You're right. So now we can balance the equation quite easily by placing a 2 in front of the hydrochloric acid and a 2 in front of the NaCl. And the equation is now balanced. Now can you see how we can make sodium sulfate? What method did you try?
Well, I added sulfuric acid to sodium hydroxide.
And I added sulfuric acid to sodium carbonate.
Those are both brilliant methods. Let's write down those equations on the board. We'll start with sodium hydroxide plus sulfuric acid. That will give us sodium sulfate plus water. Need to balance the equation. And the other second method was to take sodium carbonate plus sulfuric acid to give us sodium sulfate plus water plus carbon dioxide. And the equations are balanced.
Now what about the other 2 salts?
That's a very good question. Remember, we can make zinc salts, zinc chloride and zinc sulfate by the same 2 methods. We can add an acid plus a base or an acid plus a carbonate. Let's go back to the studio now to check out those balanced equations.
To make zinc chloride, we can use one of 2 methods. One using an oxide and the other using a carbonate. For the first method, an acid plus a base react to form salt plus water. We use hydrochloric acid and zinc oxide as our base in order to make zinc chloride. Our balanced chemical equation is 2HCl plus ZnO react to form ZnCl2 plus H2O. And for the method, an acid plus a carbonate react to form salt plus carbon dioxide plus water. We use HCl and zinc carbonate as our base. Our balanced chemical equation is 2HCl plus ZnCO3 react to form ZnCl2 plus CO2 plus H2O. We can prepare zinc sulfate using the same 2 methods. Now, I'm sure you'll agree that this task has given us great practice in writing equations. and I'm sure you're quite used to using the different methods to prepare salts. But did you know that there's one other reaction of acids that can be used to make salts? We have seen it before, but in this lesson we are going to focus on this reaction. It is the reaction of an acid and a metal. Let's take a look at our outcomes for today. By the end of this lesson, you will be able to identify the products formed when an acid reacts with a metal and write balanced equations for salt preparations. Let's go to the lab to see how zinc reacts with sulfuric acid.
In this test tube, I have some zinc metal. I'm going to add some dilute sulfuric acid to it, but at the same time, I'm getting ready a piece of splint to test for a gas that may be released. There is a gas being released. Let's test it with a splint. Did you hear? It made a popping sound. This confirms that it must be hydrogen gas.
Now, let's see what was happening in that reaction. We added zinc to sulfuric acid, which is Zn plus H2SO4. Now, hydrogen gas was released, so we can write H2 as one of the products. So, what is the other product? It must be the salt, zinc sulfate, with the formula ZnSO4. This gives us the equation. Zn plus H2SO4 react to form ZnSO4 plus H2. Now, we could collect this salt after the water from the dilute acid has evaporated. What has really happened here is that the zinc has displaced the hydrogen from the acid to form a salt and hydrogen gas. Now, this method is not often used for salt preparations for some very interesting reasons. To explain these reasons, let's look at the reactivity series of metals again. Potassium, sodium, and lithium are very reactive metals. The reaction of an acid with these metals is not suitable to prepare salts of these metals. Lead, mercury, copper, and silver are all fairly unreactive metals. They do not displace hydrogen from an acid, so you cannot prepare salts of these metals by reacting the metal and an acid. Now, when the metals calcium, magnesium, aluminium, zinc, and iron react with acid, they give off some hydrogen and heat. But these reactions are not too dangerous and can be used as a salt preparation. Let's take a look at today's task. Prepare the following salts using the three methods: zinc chloride and aluminium sulfate. Now, at the top of the reactivity series, we have the group 1 metals: potassium, sodium, and lithium. These metals displace hydrogen from water, so will displace hydrogen from an acid even more easily. These reactions are violent because they release lots of hydrogen and heat. The hydrogen can then react with the oxygen in the air in an explosion. We cannot safely use this for salt preparations, but as an exciting end to this series, let's see if John can end it off with a bang.
I've come outside because the reaction of group 1 metals and acid is extremely dangerous. So I've taken some special safety precautions. The first thing I've done is I've taken some card and I've attached a very long string to it. Then in the old plastic container, I've cut a slit and I've placed acid in the bottom of it. I've secured it with some soil at the bottom over there. Now I'm going to place the card inside to make a trapdoor. Next, I'm transferring very carefully my group 1 metal, sodium, onto my trapdoor. Just about ready to set this explosion going.
Now that's what I call a big bang. I hope you have enjoyed the series on acids, bases and salts. Remember to check out the answers to all the tasks on our website www.mindset.co.za. This will give you confidence to know that you can do really well in this section of work. Till we meet again, goodbye.